laboratory experiment for uniform quantization and pulse code modulation or PCM. I have implement this I have implement this experiment using Python and Google Colab. The main purpose is to understand how a sampled signal is covered into discrete amplitude level and then represent using binary PCM codes. Objectives. The main objectives of the experiment are four things. First, to perform uniform quantization of a sampled signal. Second, to convert the quantization index into an n-bit binary PCM words. Third, to calculate the quantization error MSE and SQNR. And finally, to validate that the quantization index and PCM words are correct. Theory. Now coming to the basic theory. The number of quantization levels and given by the number of quantization levels is given by L is equal to 2 to the power n, when n is the number of bits. For a normalized signal from -1 to +1, the quantization step size is del is equal to 2 to the power 2 by L. Each input sample is assigned to one of these levels. The quantization error is E is equal to x minus xq, when x is the original sample and xq is the quantization sample. We also calculate MSE, which represent the average square quantization error. The theoretical SQNR is approximately SQNR is equal to 6.02 n plus 1.76 dB. Therefore, when we increase the number of bits, the number of level increases and the quantization error decreases. The complete process can be represented as signal, then quantization, then index, then binary PCM words, then MSE and sonic and SQNR. For example, for a 3-bit quantization, the number of levels is 2 to the power 3 is equal to 8 levels. The indexes are from 0 to 7 and each index is represented using a 3-bit binary words. So the experiment converts to each sampled amplitude into a quantized value, then into a integer index, and finally into a binary PCM code. Now I will briefly explain the implementation. First, I generate a 100 Hz sinusoidal signal with a sampled frequency of 10 kHz and duration of 0.02 second. The signal is then normalized between -1 to +1. The next program calculate the number of level using 2 to the power n and calculate the step quantize uh, quantized step size. Each sample is converted into a quantization index. Then the quantized value is calculated using midpoint of the selected interval. After that, the quantization error MSE and sonic SQNR are calculated. The program also contained a validation check. If verify briefly if it verifies that every index is within the valid range from 0 to L minus 1. It also check that every PCM word contain exactly n bits. The experiment is simulated for a bit depth from 2 to 8 bits. The result the result for each bit's depth are stored and then used to generate the final performance table. Now coming to the result. The table clearly shows that as the number of the bits increase, the number of quantization level increases and the step size decreases. For example, at 2 bytes, there are only 4 levels and the measured SQNR is 12.80 dB. At 8 bits, there are 257 levels and the measured SQNR increased to 48.93 dB. At the same time, MSE decreases from 2.624 into 10 to the power minus 2 at 2 bits to 6.400 into 10 to the power minus 6 at 8 bits. So, higher resolution gives better signal quality. The 4-bit PCM table show how an original sample is converted into a quantized value, an integer index, and finally a binary PCM words. The original versus quantization wave show the staircase approximately caused by quantization. The staircase characteristics show that the quantization level are equal spaced. The quantization error gap shows the difference between the original and quantization signal. Finally, the SQNR versus bits graph show an increasing trend. The measured value follow the theoretical relationship of approximately 6.02 n in plus 1.76 dB. The validation results are successful for all tested bit depth. For example, uh, for 4 bit, the index range is 0 to 15 and PCM word length is exactly 4 bit. The same checks pass for all bits depth from 2 to 8 bits. Therefore, all mandatory validation checked pass successfully. Observation. The main observation from from this experiment is more bits means more levels, then smaller step size, then lower MSE, then higher SQNR. The measured result from the experiment expected theoretical trend. The measured result from the experiment expected theoretical trends. Small difference between measured and theoretical SQN can occur because of finite samples and the quantized conversion using the implementation. To conclude it, I successfully implemented inform, quantized and PCM from first principle using Python. The experiment generate quantized sample, quantization index and flex fixed length binary PCM words. The result demonstrate that increasing the number of bits reduces quantization error and improve SQNR. Therefore, high quantization resolution provides better representation of the original signal. All mandatory validation tests also passed successfully. Thank you.